Hi, today we'll discuss about the uniform circular motion. From the term circular motion, we can clearly understand that the object is moving in a circular path. When we say uniform circular motion, we mean that the object is moving in a circular path but with a constant magnitude of velocity. We know that velocity is a vector quantity and it has two components, magnitude plus direction. So, in uniform circular motion, the magnitude of velocity remains constant, but the direction of velocity changes continuously. The most common example of a uniform circular motion is the rotation of moon around the earth. There are different terms related to uniform circular motion. The first one is angular position. Let us say a particle has moved a distance d in a circular path of radius r. Then angular position theta is defined as the ratio of the distance moved by the object to the radius of the circular path it has followed. Next, we'll discuss about velocity. Velocity in circular motion has two components, the angular velocity and the tangential velocity. Angular velocity is change in angular position with respect to time. Angular velocity is also known as rotational velocity. It tells us how fast an object is moving in a circular path. Angular velocity is responsible to help the particle move in a circular path. Angular velocity is denoted by omega. For uniform circular motion, the magnitude of angular velocity remains constant. Tangential velocity is the velocity along the surface of the circular path at any point on that path. Tangential velocity is the product of radius and angular velocity. It is responsible for the particle to move forward in a circular path. Similar to velocity, acceleration also has two components, the angular acceleration and the tangential acceleration. Angular acceleration is rate of change of angular velocity with respect to time. Angular acceleration is responsible for the angular motion of the object. In uniform circular motion, since angular velocity remains constant, thus change in angular velocity is zero, and thus angular acceleration is equal to zero for uniform circular motion. Tangential acceleration can be defined as the ratio of the square of the tangential velocity divided by the radius of the circular path. Tangential velocity ensures that the object keeps moving forward in the circular path. Tangential or centripetal acceleration leads to centripetal force. The simplest example of a centripetal force is the force acting on the Earth. This force acting on the Earth helps the Earth stay in its orbit. Force is nothing but mass into acceleration. Thus, centripetal force is mass into centripetal acceleration. Now, let us solve a numerical based on uniform circular motion. A ball with weight 70 grams is attached to a rope and being moved in a circular path by whirling it. If length of rope is 10 cm and ball completes 10 revolutions in 100 seconds, then find the values of angular speed, magnitude of linear speed, magnitude of centripetal acceleration, and the centripetal force. So basically, a ball is tied to a rope and it is being whirled. So it is following a circular path. We have to find angular speed, magnitude of linear speed, magnitude of centripetal acceleration, and centripetal force. So mass of the ball is given as 70 grams, which is nothing but 0.7 kgs. Now, since the length of the rope is 10 centimeter, we can say that the radius of the circular path is nothing but 10 centimeter, which is nothing but 0.1 meters. Now, the ball completes 10 revolutions in 100 seconds. This means that it completes one revolution in 10 seconds. One revolution is nothing but 2 pi. So we can easily write omega is 2 pi by 10, which is 0.628 radians per second. Omega is nothing but angular velocity, and magnitude of angular velocity is nothing but angular speed. So angular speed is 0.628 radian per second, since we are not mentioning the direction here. Next, we have to find magnitude of linear speed. Magnitude of linear speed is nothing but magnitude of tangential velocity. So tangential velocity is equal to omega r, which is 0.628 radian per second into 0.1 meter, which gives us 0.0628 meters per second. Now next we need to find magnitude of centripetal acceleration. We just studied that centripetal acceleration is tangential velocity squared upon radius. So 0.0628 squared upon 0.1 meter will give us 0.0349 meter per second square. The last thing that we need to find is centripetal force. We know centripetal force is mass into centripetal acceleration, which gives us 0.0349 into 0.7 kgs, which is 2.76 into 10 raised to the power minus 3 Newton. With this, we come to an end of the discussion of uniform circular motion.